Hello, I'm Josh. In this video, I will be preparing a model of a 23-story building and will be running analysis and design on the same under the load combinations of dead loads, live loads and wind loads, where the wind loads parameters in Bangalore are considered as per the IS codes as the building is to be constructed in Bangalore. So we will open the ETAP software in which we will open a new model, set the display units to metric SI and steel section database to Indian and the respective steel and concrete design codes as seen here. Then click on OK. The number of grid lines in X direction and Y direction are 4. Spacing between the grid lines in X and Y direction are 6 meter both. The number of stories are 23 and the typical heights are 3 meter, that is the story heights. Here we will use custom story data in which we will edit story data. As the stories 1 to 8 have similar properties, so we will initiate story 8 as a master story and the other stories will be similar to the master story 8. Now the stories 9 to 14 have similar properties, so we will define the story 14 as a master story and the stories from 9 to 14 will have the similar property of story 14, which we are setting here. Now the stories 15 to 19 have similar properties, so we will define the story 19 as a master story and other stories will have properties similar to story 19. Okay, now let's check it. The stories 20 to 23 will have similar story properties to 23 story by default. Now click on OK, select grid only, then click on OK. Wait as the software prepares the skeleton of the model as per the grid lines we have initiated. Now we will define the materials which are to be used. Add new material, select region as India, material type as concrete, standard Indian grade as M40, click on OK. These are the property of M40 concrete. Now click on OK. Now we will add another material, the rebar material, that is HYSD 500 and click on OK. Now we will add another reinforcement material, that is the mild 250 and click on OK. On OK. Click on OK. Now we will define the sections, that is the slab sections and frame sections. First we will define the frame sections, in which first we will define the column sections. C 500 into 500, material M40, depth 500, width 500, modify short bar, just select column. Longitudinal bars will be HYSD 500 and confinement will be Y250. Duct cover will be 40 mm. Then click on OK. Click on OK again. Now add a copy of this property to just make a change in the dimension while the other properties remain the same. We will be adding 3 different dimensions of both column and beams. Now we will add the beams, concrete rectangular, beams of 500 into 300, material M40. Now obviously in the case of beams the depth will be greater than the width. Here select beam as it is a beam. The cover will be 25 mm in the case of beams. Click on OK. Now click on OK. Now add a copy of this as we did for the columns. The properties will remain the same except dimensions, section dimensions. Now click on OK. Now we will define the beam and column auto select. Here we'll select the material as concrete, then select the columns and add them up here, and then click on OK. Here modify the name of this column as 550 into 550. Now click on OK. Let us check again in the column auto select. Now it's OK, 550 into 550. Now click on OK. Now we will create the beam auto select list. Add them up here, then click on OK. Now as we have defined them, click on OK. Now we will define the slab section which is to be used. It is of thickness 152, so we will give name as S150, material M40, thickness as 150 mm. Then click on OK. Then click on OK. OK. Now we will draw the columns first in the storage having similar properties from 1 to 8. So select similar storage option here. On in draw, select quick draw columns, set the column property to column auto select, then select the columns. Now we will go to storage 9 to draw the columns having similar properties. Okay, now we will go to storage 15 to draw the columns. Make sure that the property is set to column auto select. Now we will draw the columns in storage 20 to 23. Here as shown in the 3D model, the columns are drawn. Now we will draw the beams. We will start from storage 20 to 30 group. Select quick draw beams. Here select the property as beam auto select, then select the area to draw the beams. Now we will go to the other group. Okay, now we will go to the next group. Now we'll go to the next group. Okay, select escape. Now we can see in the 3D view that the beams and columns are drawn. Now we will draw the slabs as per the defined dimensions. So we will select quick draw floor, select the property as S150, then select the area to draw the slabs. The software is a bit slow as it is an evaluation version. Now we'll go to the other groups of storage. Now to the next group of storage. Make sure that the property is maintained. Okay, now press escape. Now we will give the dead loads and live loads to the slabs. So as in assign, select cell loads, select uniform, dead load. The dead load we have to assign is 2 kilonewton per meter square. Sorry, first we will select the shells. Then we will assign the dead loads and live loads. Shells, uniform, dead load 2 km square, apply. Then click on OK. Now we will get the previous selection from select and we will assign the live load of 3.5 kilonewton per meter square. Here select live load 3.5 kilonewton per meter square, apply, then click on OK. Now we will go to the another group of storage. OK. Now we will assign the dead loads first. Just select dead 2 kilonewton per meter square, apply, then click on OK. Get the previous selection, then click on assign shell loads uniform, live load. The live load of 4 kilonewton per meter square will act. Now to the another group of storage. Assign shell loads uniform, dead load of 2 kilonewton per meter square, apply, then click on OK. Assign shell loads uniform, live load of 4.5 kilonewton per meter square, apply, click on OK. Now we will assign dead loads and live loads to the next group of stories. Make sure that your selection is correct every time by checking the calculation. Assign shell loads, uniform, dead load 2 kN per meter square, apply, click on OK, get the previous selection, assign shell loads, uniform, live load of 5 kN per meter square, apply, then click on OK. Now we will draw the cladding walls. Draw, select the 3D view, click on draw, select auto draw cladding, select use flows option. Wait. Okay, now you can see that the claddings are being drawn. Here the software is a bit slow. You can see in the 3D view that the claddings are drawn. Now we will give the dead weights, that is the self weights of claddings onto the outer beams of the similar storage group. Make sure that the similar storage option is selected on the bottom right corner. Assign frame loads, distributed dead load 0.2 kN per meter square. Click on apply. Then click on OK. Now we will go to the next group of storage, where we will select the outer beams as claddings is present only on the outer beams, upon the outer beams. Okay, now we will select assign frame loads, distributed dead 0.2 kN, apply, then click on OK. Now we will assign the dead load, that is the self weight of claddings, to next group of storage. Make sure that you select the outer beams only. And no shells are selected by mistake. Okay, then assign frame loads, distributed 0.2 kN, and click on apply. Then click on OK. Now to the next set of storage. Assign frame loads, distributed dead load of 0.2 kN square, 0.2 kilonewton per meter. Click on OK. Now we will apply the bin load. So first define in load patterns, add a new load, Okay, first we will give a new name, that is the wind. Select here wind. Here we will select its IS code, that is in the IS 875/1987. Select on add new load. Now we will modify this lateral load. Now as per the IS codes, the wind speed VB in Bangalore region we will determine from the IS codes. So let us get back to the IS codes, where here we cannot see the values properly as there is not proper image. So we will check in the appendix A clause 5.2, where the list of the different values in different regions are given. Region Bangalore, the VBE value is 33 kilonewton per 33 meter per second. The terrain category, sorry, here the we can see that the category 3 is suitable as the building is constructed in Bangalore, and Bangalore is a well furnished area, so the category 3 is suitable here. So we will select the terrain category as 3. Now for structure class we'll refer to the IS codes. uh, Structure class includes the greatest horizontal or vertical dimension here is 69 meter. 23 stories of 3 meter height, there is 69 meters, so structure class will be C. There is coefficient factor here for 33 meter per second value. We are assuming that the building is made such that it will last for 50 years. That is, the design life of building is of 50 years, so the value of K1, that is the risk factor, will be 1. So set it as 1. And topography K3 factor, the the upwind slope in the Bangalore region will have an angle less than 1, will have an angle less than 3 degree. Thus the value of K3 will be taken as 1. Okay, then click on OK. Now click on OK. Now we will apply the wind coefficients as per the IS codes to the surfaces on the windward and leeward sides. So select the plan view, select the animation, set up the section elevation view to A, then apply, then click on OK. Select here from display, select undeformed shape to get this option, and from here select all storage and select this. Now what coefficient we will give this, we will see from the IS codes, that is for rectangular sections. For here the height is 69 meter and width is 20. Here the height is 69 meter and the width is 18 meter. So the height by width ratio will be 3.83. That is between this, that is in this group. Now the length by width ratio is 1, that is will be in this group. So the Wind coefficients on the surfaces A will be 0.8, B on the surface B will be 0.25, and C and D will be 0.8 both. So init apps, as we have selected all the shells, now we will go to assign shell loads, wind pressure coefficient, wind, select the windward side and the coefficient as plus 0.8. On apply, then click on OK. Now select the other elevation view, that is B. As some of the sections are behind A, so it won't come in the A section, so they will come in the B section. Select them, then apply the coefficient of plus 0.8 by doing the same process. Windward, apply, then click on OK. Now go to the elevation of D and C. Click on apply, and click on OK. Select all storage. Sorry, deselect as I selected the shells. Sorry, frames. As we have selected the shells, we'll give the coefficient value as to B side. The value will be minus 0.25. So assign shell loads wind pressure coefficient as minus 0.25. Select the option leeward, as it is a leeward side, opposite side from the windward side. Apply, then click on OK. Now we'll go to the section C. Apply, click on OK. OK. Now we will assign the same value to this group of shells as they are behind the D section. Click on apply, then click on OK. Now we will go to the section, sorry, I selected the plan view. Select the elevation view and go to 1, apply, click on OK. Select all, OK. Now assign the shell loads wind pressure coefficient value as minus 0.8. Leeward, as it is the side, so select this option only. Apply, click on OK. Now go to the 3D view. So that you can change this elevation sections from the up and down arrows. Next we will be seeing the elevation in 2. Select them, assign shell loads wind pressure coefficient minus 0.8, apply, then click on OK. Now go to the elevation view in 3. Sorry, I selected the frames by mistake. Assign shell loads wind pressure coefficient, apply, OK. assign shell loads, pressure coefficient pointed, apply, select OK. Now as we have assigned, now select a plane of any storage, apply, on OK. Here we can see that we have applied the wind loads to all surfaces of all storage. Now we will run the analysis and design under this load combination. You can see the load combination here. We will run analysis. First we will save the file from building assignment, save. Wait while the analysis is being run. Okay, so now here we can see the deformed shape. We can see the different diagrams such as from display, such as the shear force and bending moment diagrams. Here select shear V2 to apply. Okay, this is the shear diagram, this is the movement diagram. Click on OK. Now we will run design on this. Here this is a concrete frame design, so here make sure that the IS code is selected. Click on OK. Now we will run the design. Start design check. Here 700 concrete frames failed, so it is asking us to reiterate the analysis by taking the different sections from the beam and column auto select. So we will select yes. It will again run the design as it is reiterating. It has started running the design again. Now 11 frames are still failing. We'll select yes to reiterate. Well, concrete frames, yes. Now as it is an evaluation version, it is having this problem. We'll click on no. Here we will check that whether all members are passed or not. Concrete frame design verify omegas. Go. Okay. So there have been some error. Now we will give them the properties. Of the Now I have fixed the problem, so now let's check whether all members are passed or not. Verify all members pass. All concrete frames pass the design check. Okay. Now here are the longitudinal reinforcement values. Here I can't run the reinforcement design check as the software is an evaluation version, and so that option is not present. We can get the summary project and summary report by clicking on it. Wait, as the report is being generated. Here is the report giving the details of the dimensions and everything of the model.